All right, let's work out some problems, the Earth application problems. The Earth's radius is about 3,963 miles at sea level, and we need to calculate the angular velocity. Well, first, we need to start with some type of angular velocity so we can get the angular velocity in radians per second. Well, I know that the Earth makes about one revolution in 24 hours. And take this angular velocity, angular over time, change it into radians per second. Okay, one revolution, there are 2 pi radians. So now my revolutions units cancel, I now have radians. Let's change hours to seconds now. Well, in 1 hour, there are 60 minutes, and then in 1 minute, there are 60 seconds. And you might be asking, could I have just went 1 hour is 3,600 seconds? Yes, you could have done that. Hours units cancel, minutes units cancel. Doing unit analysis, I have radians over seconds, which is what I wanted. All right, in the numerators, we multiply across. Looks like we have 2 pi radians in approximately 60 times 24, which is about 43,200 seconds. Now, decimal approximation, we get about 0.0000727 radians per second. Okay, let's move on to part B. We need to know the linear velocity in miles per hour of a point at sea level. So as you're rotating, change the angular velocity to linear velocity. Well, again, let's start out with our angular velocity for a point at sea level. We can start out with either 1 revolution is 24 hours, or we can say 2 pi radians is 24 hours, because we know there's that relationship just by looking right here. So I'm going to start out with 2 pi radians in 24 hours. I need to convert radians per hour into miles per hour. So our hours unit is already okay. We need to convert radians to miles, change angular to linear. And how do we do that? 1 radian, by definition, is equal to the radius, which is 3,963. And that unit's already in miles. So now after our radians units cancel, we actually have miles per hour. Multiply across, you got 2 pi times 3,963 miles over 24. Decimal approximation, that's about 1,037.51 miles per hour. Check our units, we have miles per hour, which is what we wanted. Is this a linear velocity? Yes, it is. Okay, let's move on to part C. The elevation of Mount Everest is 29,029 feet approximately. What's the linear velocity at the highest point in the world in miles per hour? Okay, to get a linear velocity, we need to start with an angular velocity again. Well, I'll start out with our angular velocity of the Earth, 2 pi radians in 24 hours. We need to convert this to miles per hour again. Okay. Well, I know that 1 radian is equal to the measurement of our radius. What is our radius this time? Well, it's the radius of the Earth at sea level plus this extra distance to get to the top of Mount Everest. Well, I notice that this unit is in feet, so I have to convert this to miles. So 29,029 feet times there are 5,280 feet in 1 mile. That's approximately 5.497 miles. So now the radius from the center of the Earth to the top of Mount Everest is about 3,968.497. And that's in miles again. Radians cancel, and we are left with miles per hour. Multiply across, divide by 24, and you have approximately 1,038.95 miles per hour. Now, does this answer make sense? You're farther away from the center of the Earth, and you're traveling a little bit faster than if you were closer to the center of the Earth at sea level. So yeah, it does make sense because you're farther away from the center. You should be traveling faster with the same angular velocity.